Assalamu alaikum. Hello, everyone. We continue with decision trees. Before we proceed from where we left off last time, I would like to mention something very quickly. So, as I said, when we are building decision trees, at any given node, we are actually choosing the feature that maximizes the information gain, and we build a condition based on that, and we keep branching. Okay, so when do we stop? Okay, when we decide that this node is a leaf node. So one condition is that when we have all the samples that reach that node, all of them, they belong to the same class. Like, for example, here, all of the samples belong to the class false. Here, all of the samples belong to the class true. And here, all of the samples that have reached this node belong to class false. So then we stop. These are leaf nodes. Okay, but that may not always be possible. Sometimes, like samples from different classes, they reach a node, but there is no further improvement after that. And we have tried all the features and there is no further improvement. Then that we stop there and we do majority voting, okay, to decide what class we will decide for a sample that reaches that leaf node. So I would like to start from here. Actually, we stopped here last time. So we have what we call classification rules as well as association rules. Okay, what's the difference between classification rules and association rules? Let's read through these lines and try to explain that, okay? The rules that are obtained from tree, which can be used for predicting the class level, are classification rules. So for a rule, like when we traverse all the way to a leaf node and return a class, that is a classification rule, okay? So I have already mentioned here, like what do we mean by a rule here actually. So this is a rule. If and then there is a condition, then there is a result. So if what comes after then here in the result, if it's a class, then this is a classification rule. For example, look at this tree here. If age is equal to child, then the class is equal to false. Inflated is equal to false. Okay, that's a classification rule. Another classification rule we can get from this tree is that if age is adult and act is stretch, then class is true. This one here. Okay, inflated is true. That's a classification rule. So if we go all the way to a leaf node and return a class, then that's a classification rule. So there is a condition or a set of conditions. Okay, for example, here there was, when we went to this node, there was only one condition, if age is equal to child. Here there was intersection of two conditions. If age is adult and act is stretch, okay, then the class is true. So there were two conditions and then we return class, okay? Then what comes after then is a class. That's a classification rule, okay? So then there will be one rule for every leaf node, okay? And yeah, it's easy to read the classification rules from the decision tree. And yeah, so that is about the classification rules. The association rules, they can be used to predict any attribute. It doesn't need to be a class, okay? We can have if condition, then some like something happens as a result, but it doesn't need to be a class. So we can build any rule, okay? And we will see that there's an example that is coming after this that will make it very clear. So it can be like if something happened, then the other thing happens. Okay, we put that rule, but then we check that what we call the support or the coverage of that rule, which is the number of instances for which it predicts correctly. Like when that rule is really correct, okay? That's called the support or the coverage. And the accuracy is actually the number of instances that it predicts correctly, expressed as a proportion of all instances in which it applies. So maybe let me look at the example because the example will explain it very well. I can explain it here, but then maybe it will not be as clear as if you look at the example. Let's look at the example and then we come back here to explain it further, okay, if needed. But I think the example will explain it very well. Let's look at this example here. We're going to build a decision tree. We're going to write two classification rules, and then we're going to write association rules. We will look at this. Okay, let's start by just first building the decision tree. So here we are reading the content of this file. Then we do one-hot encoding to transform all the features to numeric ones. Okay, so we have 4 features and the class label. So all of them are now transformed to numerical attributes. Okay, some of these, like these two, for example, they have 3 choices. Okay, so they will be encoded into like 2 columns here because we're dropping the first one. So then here we have more features than we used to have for the categorical version of these attributes. So for example, for the first one, we have Outlook underscore rainy and Outlook underscore sunny. Okay, because Outlook underscore overcast was dropped. And also same thing for the temperature cool was dropped. So we have temperature underscore hot and temperature underscore mild. Okay, these are the numerical features. Okay, so here we build the classifier. We create the object and we fit the classifier object, and we fit the classifier object into our data. Here we pass all the features after dropping the target variable, and here is we pass the target variable as the second argument, and we run that, we get this tree. Okay, now let's look at let's extract classification rows. By looking only at this part, I can actually extract 2 classification rows. Okay, the first rule is if humidity is not normal, so we come here. If humidity is not normal and outlook is sunny, then play is equal to no. That's the first rule. Okay, it's the second here. If humidity is not normal and outlook is sunny, then play is equal to no. No, that's a classification rule. Okay, so we have intersection of 2 conditions here. This is what comes after if. This intersection of these 2 conditions, and what comes after then the result is the class label. Okay, so for a classification rule, we have to traverse all the way to the leaf node, to one of the leaf nodes. Okay, another rule I can come up with, it comes through this path here. If humidity is normal and outlook is not rainy, then play is equal to yes. Okay, if humidity is normal and outlook is not rainy, then play is equal to yes. Okay, so just one thing to mention here, why the color here is white, because here we have equal number of samples from both classes. That's why the color is white. So if it's dark blue, then that's all of the samples are belong to class yes. If it's orange, clear orange, then all of them belong to class no. And if it's a mix of these 2 colors, then there is a confusion here. There are samples from each one. For example, here it's a bluish because there are more yes samples than no samples. Okay, so it will get more bluish if there are more samples from the yes class, and it will get more like closer to orange if there are more of the samples that are belong to class no. Okay, so one thing also to mention, this rule I said if humidity is not normal, and because humidity has only 2 options, is either normal or high, I could have also said if humidity is high, because if it's not normal, that means it's high. If humidity is high and outlook is sunny, then play is equal to no. For this branch here, I could have here for the first part, I said if it's normal. Okay, if it's normal. For the second part here, If it's not rainy, I have to say if it's not rainy, because if it's not rainy, it could either be sunny or overcast. So I cannot say, for example, if it's normal, if the humidity is normal and outlook is sunny, because when we come here, it could be sunny or overcast. So by default, this using decision tree classifier, we are building binary decision trees where from every node there will be two branches. So this branch will we will come here if it's rainy, but if it's not rainy, which could in that case it could be sunny or overcast, we will come here. Okay. We could have built a decision tree where we have three branches. Okay, one for rainy, one for sunny, and one for overcast. Okay, but as I said, by default here, uh, uh, decision tree classifier builds binary decision trees. Okay, where we have only two branches from each node. Okay, now let's come to how to build an association rule. Okay, so here in the question, we want to build association rule of this kind, temperature to humidity. So temperature will come after if, so the condition will be on the temperature and the result will be on the humidity. Okay, let's look at different options, different rules we can build here, and which one has the highest support and what is the value for the support and the accuracy for that one. The first thing we do here, we actually extract that slice. Okay, the slice, because we focus only in these two columns. So we extract all the samples for these two columns, the temperature and humidity. And we sort them by the value of humidity. Is just like for convenience, like when you look, all high come under each other and then normal. Okay, so we extracted all the samples, okay, and only these two columns. Now looking at this, we can build different rules. For example, one rule is if temperature is hot, then humidity is high. That's one rule we can build. Another rule, if temperature is mild, then humidity is high. Another rule, if temperature is cold, then humidity is normal. Okay. Another one, if temperature is hot, then humidity is normal. Another one, if temperature is mild, then humidity is normal. Now, which one has the highest support? Which one has like occurred the most? So this is like if temperature is cool, then humidity is equal to normal. This has a support of 4. 1, 2, 3, 4. It has predicted that correctly 4 times. If I put this as a rule, then I would say this rule was applicable 4 times. Then the support or the coverage is equal to 4. Okay, this also has a support of 4. We have two rules that are like, they have a support of 4, which is the high support or the coverage here, as we can see. For example, for hot, if temperature is hot, then humidity is high. This has support of 3. Okay, this has support of 4. 1, 2, 3, 4. If humidity is mild, sorry, if temperature is mild, then humidity is high, has a support of 4. 1, 2, 3, 4. Okay, but here the temperature was mild, but the humidity wasn't high. It was normal. Okay, so then this has a support of 4, but what about the accuracy? So the accuracy is 4 out of 5, right? 4 over 5, right? Sorry, 4 over 6. Okay, there are 2 times here. Okay, so the accuracy is 4 over 6, 2/3. The accuracy is 2/3. Okay, 0.67 or 67, 66.67% of the time we will be correct. Okay, so we'll be correct 2/3 of the time and not correct for 1/3 of the time. Okay, so the accuracy is 2 over 3 and the support is 4. Okay, this one has support of 4 and accuracy of what? So whenever it's cool, whenever the temperature is cool, the humidity is normal. Okay, so then this has accuracy of 100%. The support is equal to 4 and the accuracy is equal to 100%. Okay. I hope like by now the idea of support and accuracy became clear. Okay. So now let's look at the next question here. Write the support and accuracy of the following association rule. If outlook is equal to sunny and play is equal to no, so we have intersection of two conditions, then windy is equal to true. Then we need to extract the slice that contains these three columns for all of for the samples in which this condition is applicable. Okay, then how do we do that? Simply we do it this way, right? So we extract all the rows such that the condition is applicable, and for these rows we display the content of these three columns. Okay, then by looking at that, okay, so so as you can see, we extracted the rows in which this condition here is satisfied. Outlook is sunny and play is equal to no. Okay, so we are interested in which one. Okay, so interested what the value for windy is equal to true. Okay, we are interested on the rule that states if play is equal to no here. If play is equal to no, sorry, it's this one. If outlook is equal to sunny and the play is equal to no, windy is equal to true. This has support of 1. The support is 1 and the accuracy is 1/3. Okay, so it only 1/3 of the time predicts correctly. Okay, so 1/3 of the time this combination for these input ones leads to true for windy, only 1/3 of the time. So the accuracy is 1/3 and the support is 1. Now let's look at the last one. Okay, so the last one, write association rules for windy equal to false and play equal to no, then humidity and outlook. We need all of these, and then we need to find the one that has the highest accuracy and support. Okay, let's first display all of these. So the condition is when play is equal to no and windy is equal to false. Then we need to we extract all these like the rows that satisfy these conditions and all the columns for those samples or rows. Okay, so when windy is equal to false and play is equal to no, so when we are conditioning in these two, the outcome for these two is the same. When this is false and this is no, this will be high and that will be sunny. So it will always be this. So this is the rule we have. So it's one single rule. When windy is false and play is no, humidity will be high and outlook will be sunny. Okay, that's the rule we have. It has support of 2. Okay, and the accuracy is 100%. Okay, these are the answers are written here. Okay, this has support of 2. This rule, the rule that is when windy is false and play is no, humidity is high and outlook is sunny. This has support of 2 and accuracy of 100%. With that, we reach to the end of today's class. Let's stop here and see you next time. Assalamu alaikum. Thank you.